Hi, welcome to MyProjectBazaar.com. Now let me discuss about the title of the process. The title of the process is BDCaM, that is Big Data Aware for Context-Aware Monitoring, a personalized knowledge discovery framework for assisted healthcare. Now let me discuss about the abstract of our process. In the existing system, they developed a cloud-oriented context-aware middleware. They described the context-aware service identification process using high-level generalized medical rules. It proved its advantages for processing and managing large amount of context gathered from multiple AAL systems. It improved the knowledge of understanding the patient's situation through iterative learning of present context and substantial historical data can reduce the transmission of repeated false alerts to the remote monitoring systems. So context awareness is nothing but a location awareness process. So context aware computing refers to the general class of mobile system that can sense their physical environment and adopt their behavior accordingly. An ambient assisted living AAL system consists of heterogeneous sensors and devices which generate huge amounts of patient-specific unstructured raw data every day. BDCaM that uses cloud computing platforms. Every generated context of AAL systems are sent to the cloud. A number of distributed servers in the cloud store and process those contexts to extract required information for decision making using this novel technique. We develop a two-step learning methodology. In the first step, the system identifies the correlations between context attributes and the threshold values of the vital signs. Using a MapReduce API algorithm, it generates a set of association rules that are specific to the patient. In the second step, the system uses supervised learning over a new larger set of context data generated using the rules discovered in the first step. Further, our system improves efficiency and accuracy in terms of time and storage. This is abstract of our process. Now let me discuss about the data flow diagram of our process. First, data collector collects the data, AAL system data. So here we are collecting profile data, medical records and activity logs. After that, we have to store into the context aggregate cloud. It will be embedded into the cloud. So in the context management cloud, here we collect the data. After that, we apply the fuzzy. After we have to generate the rules. After that, we have to extract the features. After that, we have to match the rules. After that, we have to, by using the rules, here we classify the records. So here context informations will be as activity, location and environmental status. So based upon the rule matching, here we classify the results. So after that, we predict the unknown activity and unknown activity of the users and predict the patient disease and symptoms of the drug. This is a complete demo of data flow diagram of our process. Thank you for watching. Now let me discuss about the complete demo of process. First we have to run. We are having package BDCaM disease prediction. First we have to run home.java. So just click on that frame and file. So in the project title is BDCaM Big Data for Context Aware Monitoring a Personalized Knowledge Discovery Framework for Assisted Healthcare. For activity prediction, here we have to applying for sensor dataset. So click RNA sensor. So select RNA sensor dataset and load into the database and view and back RNA ADL dataset. So go to the RNA ADL and load dataset into the database and click view and back. And for awareness B dataset, we have to select the awareness B sensor dataset and load into the database and click view and again click back. For ADL dataset, we have to choose ADL dataset and click data extraction and review information and click back. So here we have to calculate the similarity for awareness ADL dataset and BDE and for A sensor and B sensor. So after that, here we have to get time taken for particular event. And click next. Then activities time duration for grooming, and click next for B dataset. So for that each activity we have to predict the time taken and click next. So I have to store the data into the DFS. File uploaded successfully and click next. And here we have to classify the activities for prediction A, for prediction B. Non-activity and non-active will be displayed here and click next. So for predictive A and for B. These known activities and these unknown activities will be displayed here. So load into the DFS and click performance for count for user A and for user B. So based upon this, here we evaluate the performance of existing algorithm and proposed algorithm. This is a complete demo for our process. Thank you for watching.